So next topic is packing efficiency. So here packing efficiency. So packing may be in different types. Simple cubic packing, hexagonal close packing, cubic close packing, which is also called as face centered cubic packing, and body centered cubic packing. So in all these types, okay, volume occupied by the spheres, okay, the percentage of total space occupied by the spheres, that is called packing efficiency. Okay, so whatever the volume which is occupied by the sphere in a crystalline solid, that is called as packing efficiency. So packing efficiency is the percentage of total space occupied by particles in a solid, that is called packing efficiency. Okay, so we can calculate packing efficiency by using this formula. Packing efficiency is equal to packing fraction into 100. Then what is packing fraction? Packing fraction is a ratio between volume occupied by all the spheres present in a particular unit cell and total volume of the unit cell. Okay. So here packing fraction, that is equal to volume occupied by all the spheres in unit cell. That unit cell may be simple cubic unit cell or face centered cubic or body centered cubic. Okay. Then by total volume of the unit cell. So first coming to packing efficiency, calculation of packing efficiency in simple cubic lattice. Okay, here. So in simple cubic lattice, packing efficiency formula is volume occupied by one atom. Here one atom. Why? Because in simple cube, number of particles per unit cell, that is equal to 1. But because simple cube having only corner points, so total 8 corner points are there. Each corner point is shared by 8 other unit cells. Okay, so that's why only 1 by 8 part of the particle that belongs to that particular simple cube. So totally 1 by 8 into 8. So 1 atom. So 1 atom is present per unit cell of a simple cube. Okay. So volume of 1 atom by total volume of unit cell into 100. Okay. So volume of 1 atom, 1 sphere, volume of sphere in unit cell, that is equal to 4 by 3 pi r cube, by total volume of unit cell, that is 8 r cube, into 100. So this is equal to pi by 6 into 100, which is equal to 52.4%. So it indicates 52.4% of the unit cell is occupied by the sphere and remaining space is empty space. Okay. So 52.4%, that is the packing efficiency of simple cube. So this much percentage of sphere of space that is occupied by the spheres. Okay. Next coming to hexagonal close packing. And this is also called as cubic close packing or face centered cubic packing. Okay. So here packing efficiency is volume of 4 spheres in unit cell. Why here 4 spheres? So you know about number of particles per unit cell of FCC. Okay. So in FCC unit cell, 8 corner points along with 6 face centered points are there. So out of 8 corner points, only 1 corner point belongs to that FCC unit cell. Why? Because each corner point gets shared by 8 other unit cells and 1 by 8 part of it belongs to that particular unit cell. That's why 1 by 8 into 8, that is equal to 1 corner point. So FCC having 1 corner point. And 6 face center points are there, but each face center point gets shared by 2 other unit cells. Okay? So each face center point, how many face center points are there? 6. 6 into half. So 3 face center points are belongs to that particular unit cell. So 3 face center points and 1 corner point, totally 4 points are present in FCC unit cell. So 4 spheres belongs to FCC unit cell. That's why here we are writing volume of 4 spheres. Okay. So volume of 4 spheres in unit cell by total volume of the unit cell into 100. So volume of sphere, you know about volume of sphere. What is this? 4 by 3 pi r cube. So 4 into 4 by 3 pi r cube by 2 root 2 r whole cube into 100. So this is equal to pi into root 2 by 6 into 100, which is equal to 74%. So in hexagonal close packing HCP or cubic close packing or FCC, packing efficiency is 74%. So 74% of the space is occupied by spheres in HCP, CCP or FCC. Okay. So that is packing efficiency. Next, coming to body centered cubic packing. So in body centered cubic packing, formula of packing efficiency. So that is volume of 2 spheres in unit cell by total volume of unit cell into 100. So in body centered cubic unit cell, so number of particles per unit cell is equal to 2. Body centered unit cell contains 8 corner points and 1 body centered point. So out of 8 corner points, only 1 corner point belongs to that particular unit cell. Why? Because each corner point gets shared by 8 other unit cells. So 1 by 8 part of it belongs to that particular unit cell. That's why only 1 atom, 1 corner point that belongs to body centered cubic unit cell. Then it also contains a point at the center of the body, that is called body centered point. So body centered point totally belongs to that particular unit cell only. That's why body centered cubic lattice, it contains 2 points in it. Okay. So here packing efficiency is equal to volume of 2 spheres in unit cell. So volume of sphere is 4 by 3 pi r cube. So 2 into 4 by 3 pi r cube by 4 by root 3 r whole cube into 100. This is equal to pi root 3 by 8 into 100, which is equal to 68%. So this indicates in body centered cubic lattice, 68% of the lattice, 68% of the space, that is occupied by spheres, and remaining space is empty space. Okay. So in simple cube, 52% is occupied by spheres and remaining space is empty space, which is called as void space. And in hexagonal close packing, 74% is occupied by spheres and 26% is a void space. And in body centered cubic packing, 68% is occupied by spheres and remaining 32% is void space. So void space. So there are 2 types of voids, tetrahedral voids and octahedral voids. Okay.